So hello everyone. Oh my God. Okay. So good evening all. Today we are having this P block elements exercise, and we have covered up to 28 questions of NCERT exercise. We have daily class, from 8 p.m. to 8:45 p.m. So today we are starting the question number 29. Question is, how can you prepare Cl2 from HCl and HCl from Cl2 and write reactions only? So first question is Cl2 from HCl. So HCl HCl can be converted into Cl2. You know here in HCl oxidation number of chlorine is -1, and what is the oxidation number of chlorine in Cl2? It is 0. That means HCl is oxidized to Cl2. So HCl can be oxidized to Cl2 by different oxidizing agent like KMnO4, potassium dichromate, means potassium permanganate, potassium dichromate, or even MnO2. So HCl can be converted into Cl2 by using potassium permanganate, potassium dichromate, and even MnO2. So most simple is MnO2. So let's do the oxidation by using MnO2. So MnO2 when react with HCl, HCl gives Cl2 and Mn form MnCl2. MnCl2 and hydrogen and oxygen, they form water. So obviously two oxygens are there, 2H2O. So 4HCl, and this way it is balanced. That means HCl can be converted into Cl2 by using an oxidizing agent like potassium permanganate, potassium dichromate, or even MnO2. So this is the simple reaction. Okay. Now second question is to convert Cl2 into HCl, means to reduce Cl2 to HCl. Yes. So tell me. So in this case, when HCl is converted into Cl2, we are using oxidizing agent. So obviously to convert Cl2 into HCl, we have to use some reducing agent. So very simple reaction is there. Cl2 when react with hydrogen in the presence of sunlight, or we can say diffuse sunlight, we get 2HCl. So this is a very simple reaction. So in this way we can prepare Cl2 from HCl or HCl from Cl2. Okay. Next question. Question number 30. What inspired Anne Bartlett for carrying out reaction between xenon and PTF6? Yes, beta. If you have any doubt, you may ask anytime. Good evening, Manjot, Manju Kaul. Okay, so what inspired Anne Bartlett for carrying out reaction between xenon and PTF6? So PTF6 is a very powerful oxidizing agent. PTF6 is a very powerful oxidizing agent, and when this PTF6 was kept in open by N. Bartlett, he saw the formation of a compound. And when he investigated the compound, that compound formed is O2 positive, PTF6 negative. It is a red colored solid, and in this way, that means PTF6 oxidizes O2, means O2 is oxidized to O2 positive by PTF6. Now, when this compound formed by N. Bartlett, then he knew that ionization energy of O2 is very close to xenon. So he made an attempt to react this PTF6 to just to oxidize xenon by using PTF6, and he found that when xenon and PTF6 were mixed, they readily form this compound. Red solid Xe positive PTF6 negative is formed. So Neil Bartlett, it is inspired by this reaction, that PTF6 that can oxidize O2 molecule into O2 positive. And when he compared ionization energy of oxygen and xenon, he found that ionization energy of O2 is very similar or very close to xenon. Then he made an attempt to prepare a compound with xenon, and he was successful. And in this way, noble gas chemistry starts. Whole novel gas chemistry started by this first reaction of xenon with PTF6. And why he chose this xenon only? Because xenon is largest in size except radon, because radon is radioactive. So he attempted with xenon, which have lowest ionization energy among noble gases, right? Next question. Question number 31. What is the oxidation states of phosphorus in the following? First is H3PO3. Yes, beta. In H3PO3, what is the oxidation state of phosphorus? So, the element whose oxidation state we have to calculate, that is taken as X. Now, hydrogen when attached to phosphorus, it has +1, and oxygen -2. So it is 3 into 1 plus 1 into X, because only one phosphorus is there, plus 3 into -2, and whole charge equal to 0. So it is 3 plus X minus 6 equal to 0. That is X minus 3 equal to 0. So in this case, oxidation state of phosphorus is +3. In H3PO3, oxidation state of phosphorus is +3. Second one. So second one is PCl3. So chlorine is more electronegative than phosphorus. So chlorine has -1 charge. So it is X minus 3 into 1. So it equal to 0, means here again X is +3. Means oxidation state of phosphorus in PCl3 is also +3. Now third one. It is calcium phosphide. So calcium means alkali metal and alkaline earth metal. They have always fixed oxidation number in their compounds. Calcium is an alkaline earth metal, so its oxidation number is always +2. So 3 to the 6 plus 2x equal to 0. That is 2x equal to -6. So X is equal to -3. So oxidation state of phosphorus in calcium phosphide is -3. Next one, fourth one, that is sodium phosphate. So take phosphorus as X, sodium is +1, oxygen -2. So it is 3 to 3 ones are 3 plus X minus 8 equal to 0. That implies X minus 5 equal to 0, means X is +5. So oxidation number of phosphorus in sodium phosphate, it is +5. Now last one is, yes, last one is POF3. Again, take phosphorus as X, oxygen -2, and phosphorus has fluorine has -1. So X -2 -3, 3 into -1, that is X minus 5 equal to 0. So X is equal to +5. That's it. So these are the oxidation numbers of phosphorus in different compounds. Question number 30. Write balanced equations for the following. NaCl is heated with sulfuric acid in the presence of MnO2. See, NaCl we have. We can start from here. NaCl in the presence of sulfuric acid. So first of all we get NaHSO4 along with HCl. NaCl first react with sulfuric acid, so we get sodium bisulfate, or we can say sodium hydrogen sulfate along with hydrochloric acid, and then this reaction we have done before, MnO2 when react with HCl, so we get MnCl2, Cl2 and H2. Just balance it. 2, 4, and that's it. It is balanced. Okay. So in this way, just multiply this equation by 4. So it is 4 NaCl plus 4 H2SO4 plus MnO2 plus 4, to give 4 NaHSO4 plus MnCl2 plus Cl2 and 2H2. So this is the balanced equation when NaCl is heated with sulfuric acid in the presence of MnO2, right? Second is Cl2 when react with or is passed through sodium iodide in water. So Cl2, chlorine is stronger oxidizing agent than iodine. Fluorine is strongest, then chlorine, then bromine, and then iodine, because reduction potential of chlorine is very high as compared to iodine. So chlorine oxidize iodine into I2 solid and itself gets reduced, and this is the reaction, balanced reaction. Done. So this is question number 32. I hope today we should cover this NCERT exercise, and then we will start D and F block elements. Yes, how are XCF2, XCF4 and XCF6 obtained? So these all the three, XCF2, XCF4, XCF6, can be prepared directly by mixing xenon and fluorine under different conditions. So xenon, when xenon is in excess at 673 Kelvin 1 bar pressure, we get XeF2. And if xenon and fluorine is in the ratio 1:5 at 873 Kelvin and 7 bar pressure, see pressure is increasing. See, in XeF2 it is 1 bar, while forming XeF4 it is 7 bar, and while forming XeF6 it is 60 to 70 bar. Okay, and ratio is also increasing. Initially xenon is in excess, then we get XeF2. If fluorine is more than xenon in 1:5 ratio, then we get XeF4, and if it is in the ratio of 1:20, we get XeF6, right? And XeF6 can also be prepared by fluorinating XeF4, because you know O2F2 is a very good fluorinating agent, is very powerful fluorinating agent. So XeF4 can be converted into XeF6 with O2F2, right? So these are the methods of preparation of XeF2, XeF4 and XeF6. So please remember these conditions: 673, 873, 573, 1 bar pressure, 7 bar pressure, 60 to 70 bar pressure, like this. Just remember these things in mind. Xenon is in excess, 1:5 ratio, 1:20 ratio, right? If you find any doubt, please do ask anytime, okay? Yes, with what neutral molecule is ClO negative isoelectronic? So say ClO negative, you know, valence electrons of chlorine are 7 and valence electrons of oxygen are 6 and with one negative charge. So ClO negative, you know, there is O negative, and O negative is isoelectronic with F. O negative means oxygen has 8 electrons total, valence electron 6, 1 electron is gained, O negative, so 7 valence electrons. Fluorine has 7, so ClO negative is isoelectronic with ClF. And you know Cl, now next question is that molecule a Lewis base? So you know ClF can be converted into ClF3. You know ClF3 is also formed. So that means this chlorine can donate its electron to fluorine, 2 more fluorines. That means ClF is a Lewis base because it can donate its electrons to 2 more fluorines. Right? How are XeO3 and XeOF4 prepared? So you know XeO3 and XeOF4. First of all, if we hydrolyze XeF4 and XeF6, we get XeO3. Okay, so XeF4 and XeF6, when we hydrolyze them, complete hydrolysis of XeF4 will give Xa and XeO3 along with HF and O2. XeF6 on complete hydrolysis gives XeO3, and same XeF6 on partial hydrolysis. See, this is partial hydrolysis. This is partial hydrolysis, and this one is complete hydrolysis. So complete hydrolysis of XCF6 gives XCO3 and partial hydrolysis will give XCOF4. Even if 2 moles of water are used, that is also partial hydrolysis, then we get XCO2F2 along with 4HF. This is also one part of partial hydrolysis. But here question is only for the preparation of XCO3 and XCOF4. So that means partial hydrolysis of XCF6 will give XCOF4 and complete hydrolysis of XCF6 will give XCO3. Right? Yes. Very conceptual question and very important as well. Maybe question in this year, there may be a question from these orders. So just focus on the explanation. Arrange the following in order of property indicated for each set. First is fluorine, chlorine, bromine, iodine. So if you think normally, so as size of the atom increases, element bond length increases. As size of element increases, element bond length increases. So element bond strength decreases. See, element bond length increases, so element bond strength decreases, right? So that implies that bond dissociation enthalpy decreases as we go down the group. That means order should be F2 is greater than Cl2, then Br2, then I2. But there is a twist because of very small size. Fluorine being very small in size, there is large inter-electronic repulsion between non-bonded pairs. Because fluorine is very small and each fluorine has 3 lone pairs, and because of very small size, they are very close to each other, and that's why there is a large inter-electronic repulsion between the non-bonded pairs of electron, and that will provide the favorable condition for its breaking. And that's why bond dissociation enthalpy of fluorine F2 is less than chlorine. Even it is less than bromine. That means order is I2 is least and then come F2. Why F2 comes in between? Otherwise order should be I2 less than Br2 less than Cl2. It's okay, but fluorine should be here. It is not at this position because of its very small size. That's why it is here. So this is the exact order. Very important question. Second is HF, HCl, HBr, HI. So as we go down the group, what is acid which give H plus ion readily, easily? Okay. So as we go down the group, H element bond length increases. So H element bond strength decreases. So as bond strength decreases, it is easier to get H plus ion, and that's why acidic strength increases. So what we write? A size of element increases, as we go down the group. So hydrogen element bond length increases, bond length increases. So hydrogen element bond strength decreases. So it will H plus ions is given by He easily. So acidic strength increases. Acidic strength increases. That means HF जो है, that is weakest, then it is HCl, then HBr, and at the end it is Hi. Okay. Now next part is basic strength. Basic strength of NH3, PH3, ASH3, SPH3 and BiH3. So nitrogen, phosphorus, arsenic, antimony and bismuth. Down the group, again size increases, and in NH3, PH3, ASH3, SBH3 or even BiH3, there is one lone pair. On each molecule, but size increases because size of the central atom increases, so overall size of the molecule increases. So electron density decreases. Electron density decreases as we go down the group. So electron donating power decreases because more is the electron density, greater is the electron donating power. So as electron density decreases, so electron donating power decreases. So as electron donating power decreases, its Lewis base character decreases. That means NH3 is most basic. Then it is PH3, ASH3, SBH3 and BiH3, because as size increases, electron density increases. Size increases, so electron density decreases, and that's why its electron donating power decreases. So is the basic character. Done. Question number 30. It was 36 na? Last question was yes 36. 37. Which of the following does not exist? Yes beta, tell me which of the following does not exist? XeOF4, NeF2, XeF4 or XeF6? Yes. Yes beta, fast, tell me which of the following does not exist? So beta, you know, ionization energy of neon is very high as compared to xenon, because you know, as we go down the group, size increases, so hold on the electron decreases, and therefore ionization energy decreases. That's why ionization energy of neon is very high as compared to xenon. That's why NeF2 does not exist, because neon does not form bond. So neon compounds does not exist. NeF2 does not exist, right? Rest of the compounds are of xenon, so they do exist. You know, XeOF4, XeF4, XeF6, they do exist because ionization energy of xenon is less and can be easily oxidized by O2 and F2. Varsha Pramar, good evening, beta. Now, question number 38. Give the formula and describe the structure of a novel gas species which is isostructural with, first is ICl4 negative. ICl4 negative. So, you know, in ICl4 negative, there are 4 bond pairs because at number of atoms attached to the central atom, that gives us bond pairs. So there are 4 bond pairs, and how many lone pairs? See, iodine has 7 valence electrons, 1 electron negative is gained. So 8 valence electrons, out of 8, 4 are shared. So how many left? 4 unshared, 4 are unshared. So when 4 are unshared, that means there are 2 lone pairs. So 4 bond pairs and 2 lone pairs. So if we arrange them, it is like this. Okay. So it has square planar structure. Now the species which is isoelectronic with ICl4, isostructural with ICl4 negative is XeF4, is isostructural with ICl4 negative. You know what is isostructural? Isostructural means having same structure. That means having same bond pairs and lone pairs. So in XeF4, how many bond pairs are there? Again, 4 bond pairs, because 4 fluorine are attached to xenon. And in xenon, there are 8 valence electrons. Out of 8, 4 are shared with fluorines. So how many left? 4 left unshared. And that's why there are 2 lone pairs. 4 bond pairs and 2 lone pairs. So it is Xe. It is like this. Same, it is square planar. Okay. Second one is IBr2 negative. IBr2 negative. So in IBr2 negative, you know, there are 2 bond pairs. There are 2 bond pairs because 2 bromine atoms are attached to iodine. And iodine, 7 valence electrons and 1 negative charge. So 8 valence electrons total. 7 of its own and 1 with negative. 1 because of this negative charge. So 8 electrons. Out of 8, 2 are shared. So how many left? 6. So there are how many pairs? 3 lone pairs. 2 bond pairs and 5, 2 bond pairs and 3 lone pairs, means total 5 pairs of electrons. So when they are arranged, geometry is trigonal bipyramidal. 3 pairs are arranged like this. So its structure is linear. 2 bond pairs and 3 lone pairs. So its structure is shape is linear, and XeF2 is isoelectronic with it. So in XeF2, again there are 2 bond pairs, total 8 electrons. Xenon has 8 valence electrons. Out of 8, 2 are shared. So how many left? 6. So 3 lone pairs. So it is like this. That means this is linear. Third one is BrO3 negative. BrO3 negative. BrO3 negative. So in BrO3 negative, there are 3 bond pairs. Now there is a twist. See, oxygen is divalent. There are 3 bond pairs. This is as per Vesper theory. Keep in mind, it is as per valence shell electron pair repulsion theory. Okay, according to that, it has 3 bond pairs because, according to Vesper theory, only sigma bonds are taken into account. Between 2 atoms, there is only 1 bond pair, or even double bond and triple bond are taken as single super pair. Okay, so there are 3 bond pairs, but each oxygen is divalent. So each oxygen take up 2 electrons from bromine to complete its octet. So total electrons shared are 6. See, bond pairs are 3. Bond pairs are only 3, but electrons shared are 6 because oxygen is divalent. Before that, we are dealing with chlorine, chlorine or fluorine. So they are monovalent atoms. Okay. So total 6 electrons are used out of 6. Now bromine has 7 valence electrons and 1 negative. So total 8 electrons. Out of 8, 6 are shared. So 2 electrons left unshared. So there is 1 lone pair. 3 bond pairs and 1 lone pair. So when they are arranged, arrangement is tetrahedral, but shape is pyramidal. And 1 negative, so 1 single bond with oxygen. Number of negative charge indicates number of single bonds with oxygen. The rest are double bonds. So it is trigonal pyramidal shape, or simply write pyramidal shape. So on the same line we have XeO3 is isostructural with BrO3 negative, because XeO3 there are 3 bond pairs. Again, xenon has 8 valence electrons. Out of 8, 6 are shared because each oxygen involve 2 electrons, share 2 electrons. So again there is 1 lone pair, but in this case it is neutral. That's why there are double bonds only. So it is pyramidal in structure. Okay. Question number 39. This is second last question. That means we are almost done. Why do noble gases have comparatively large atomic sizes? Noble gases generally do not form bond with its own atoms. They are independently exist as a monoatomic gases, and that's why there are van der Waals radii. In noble gases, there are van der Waals radii, but in other atoms of its period, there are covalent radii. And you know, van der Waals radii are always larger than the covalent radii, because in covalent radii, there is a overlapping of the electron cloud. There is overlapping of electron cloud. That's why covalent radii is always smaller. But in van der Waals radii, there is no attachment of electron clouds. They are away from each other. Therefore, covalent radii is always larger than the van der Waals radii is always larger than the covalent radii. So just write, in noble gases we measure van der Waals radii because they are not forming covalent bond with the other atom of the same gas. Okay, so their size is largest. Okay, last question. It was written by my daughter. She's in 5th standard. List the uses of neon and argon gases. First, uses of neon. So neon, it is completely theoretical question. I have just written the notes. Neon is mainly used in discharge tubes and fluorescent lamps. You know, neon bulb or neon tube is used uh, by in cars, fog lights. You know, those are neon lights. For and this neon mainly used in discharge tubes and fluorescent lamps for advertising purposes. And neon, when used in a discharge tube, it produces orange red glow. Produces orange red glow, which can be seen at long distance, even in mists and fogs. That's why they are known as fog lights. However, when neon is mixed with other gases and used in discharge tubes, different colors known as neon signs are produced. And these are widely used for advertising purposes, and neon bulbs are also used in botanical gardens and even greenhouses. Neon has a remarkable property of carrying extremely high currents even under high voltage. Therefore, neon is used in safety devices for protecting electrical instruments such as voltmeter, relays, and rectifiers from high voltage. Or it is used in beacon light as safety signal for air navigators, since its light has fog penetration power that we have discussed just now. Fog lights of the car, they are neon bulbs. It is used for filling sodium vapor lamps. It is also used for filling sodium vapor lamps. Argon. Argon is used mainly to provide an inert atmosphere in high temperature metallurgical processes such as arc welding of metals and alloys. In the lab, it is used for handling substances which are air sensitive, and it is used in filling incandescent and fluorescent lamps where its pressure retards the sublimation of filament and thus increases the life of the lamp, because its pressure does not allow metal to or filament to sublime, to convert into vapor. Okay, that's why it increases the life of the lamp. And it is mixed with neon in neon signals for obtaining lights of different colors. Okay, so that's all about the uses, and this is all about p block elements. We have done its um, in text questions, examples, and NCERT exercise. All the questions we have covered, and no question will come out of these questions. So you will get full marks in your exams if you will do all these questions. Okay, so all the best. Now in the next class onwards, we will start D and F block elements. Our class is daily from 8 p.m. to 8:45 p.m. from 8 p.m. to 8:45 p.m. Okay, it is daily from 8 p.m. to 8:45 p.m. So be ready for the next chapter, that is on tomorrow. So see you at 8 p.m. tomorrow. All the best, and do like and subscribe my channel as well as share with your friends. Okay, so bye bye. Manjot, we will discuss later on. Okay, tomorrow you may call me. Okay.